Computer programs are able to make decisions. So making decisions is fundamental to the writing of code in any language, and of course we're looking at Python here. Here you can see a selection construct that we've looked at in previous videos, and here you can see an iteration construct. Now if we look very carefully at both, we can see that both rely on a test or a condition, so also sometimes called a conditional test. But the key to these tests or conditions is that they have a true or a false result. Now, the ability of a computer to decide whether something's true or false is fundamental to the building up of algorithms, which are solutions to a specification. And what we're going to look at in this particular video are things called relational operators, which help return true or false, and sometimes they're called comparison operators. Let's therefore have a look at Python's relational operators, as we've already said, sometimes called comparison operators. And here we can see the table that I wish to refer to. Now in this column we can see we have some mathematics symbols. The equal sign, the not equal to, the greater than, the less than, the greater than or equal to, and the less than or equal to. Now those are the symbols as they appear in mathematics, and hopefully you have an understanding of that from your study of maths. If not, we will cover them in full here. However, we cannot use some of these symbols in Python. We have to use these. So let's just have a quick look at this particular operator here. We can see there is two equal signs. Now what I want to stress at this point, there is no space between those two equal signs. But this is the operator that we use within the Python language to ask, is something the same as something else? Is something equal to something else? Now this symbol means not equal to, and we can see that too is different to the mathematical symbol. This one is greater than, this one is less than. We can see they're identical to the equivalents in the math symbols for the same thing, and here we can see greater than or equal to, and this one is less than or equal to. And with these two, I wish to stress again, there is no space between each of the symbols. Let's have a quick look at how these particular relational operators are used. Here we can see we have x and y, and these are variables within Python, and x will hold a value and y will hold a value. And this symbol in the middle is asking, is the value stored in the variable x greater than the value that's in y? And what we have here, we have x and the y being operands, and we have the symbol in the middle being an example of an operator, and just one of the operators that we've chosen from the table. So if x is greater than y, if the value stored in x is greater than the value stored in y, then this will return true. If, however, the value of x is not greater than the value of y, this will return false. And also, think of this one, if x was the same value as the value in y, this would also return false, because we're asking, is the value of x greater than the value of y? Here you can see I've produced a computer program, which is shown here, and I've overlaid the runtime, which we can see is shown here. Now if we have a look at the program, here I have set a variable x to hold the value of 1, and on this line I'm asking, is x greater than 1? Well, obviously this means is 1 greater than 1, because x has the value of 1. And of course it isn't, so we would expect the output to be false. This line is asking, is x less than 1? Well, that's asking, is 1 less than 1? Because remember, throughout all of these, x has been set to 1, and that obviously is false. This one is asking, is x greater than or equal to 1? Well, it isn't greater than, but it is equal to, so that one, as we can see, is true. This one is asking, is x less than or equal to 1? Well, it's not less than, but it is equal to, so we can see it's true. This one is asking, is x equal to 1? Is x the same as 1? Well, obviously it is, it's 1, so that will be true. This one is saying x is not equal to 1. X has the value of 1, so this is saying 1 is not equal to 1. But that statement is clearly false, because x does equal 1. So saying it doesn't equal 1 is a false statement. Now the next one, that's asking is x greater than 2, which is really asking is 1 greater than 2, which is obviously false. This one is asking is x less than 2? Well, it's 1. 1 is less than 2, so that's true. This one is asking is x greater than or equal to 2? Well, it's not greater than because it's 1, and it's not equal to because it's 1, and it's obviously 1 is not equal to 2. So this on both counts is false. And what I mean by both counts is greater than or equal to. This one is asking is x less than or equal to 2? Well, x is less than 2. It isn't equal to 2, but it is less than 2, so that is true. This one is asking is x equal to 2? Is x the same as 2? Well, it's 1, so it can't be. 1 is not the same as 2, so that's false. This one is asking is x not equal to 2? It's 1, and 1 is not equal to 2, so this gives us true. And again, this is one that tends to catch people out. So hopefully you'll see that these are pretty straightforward, and the ones that may get you caught out when you're looking at them are these two here. So just be careful of that one. And what I recommend is you write a program that does this. Now obviously this is a nonsense program, it's not part of anything sensible, it's not implemented as a specification, it just enables us to look at relational operators. And of course throughout I've used x, and I've set it as 1, and I've compared them to different values. I could have had x on one side with the value and y on another, as we can see here. But I've chosen just to do this to demonstrate each of the relational operators that appeared in the table. And I strongly recommend that you, after you finish viewing this video, look around yourself with some examples of code. Let's consider this specification. Write a program that asks users to enter their age. If they are 60 years of age or older, then they are informed that they can apply for a concessionary travel card. Otherwise, they are told they are not eligible for such a travel card. Now I'm going to show the solution for this using a Nash-Snyderman chart or an NS chart. Now obviously the first step is to obtain the user's age, and then we need to follow that by a selection construct. And of course, what we're really saying here, when we obtain the age at this step, if they are old enough, then we display you can apply. If, however, when we enter the user's age, they're not old enough, then we display you cannot apply. So it's about what do we actually put here. This is the test, this is the condition, this is the conditional test, however we describe it. And this is what we place in this position. Is age greater than or equal to 60? Now let's say they were 59. So we enter 59 at this step. Is age greater than or equal to 60 when age has the value of 59? Well, 59 is not greater than 60, and 59 is not equal to 60. So it's false. So the program would display you cannot apply. Let's go now, enter another value here. Let's enter 60. So this here will actually mean is 60 greater than or equal to 60, because 60 is stored in age. Well, obviously it's not greater than 60, but it is equal to 60. So this will return true, in which case we will display you can apply. Now, of course, if we're going to look at boundary testing, I've got to consider 61 here. So if at this stage we enter 61, this is asking is 61 greater than or equal to 60? Well, it's not equal to 60, obviously. 61 is not equal to 60, but it is greater than 60. 61 is greater than 60. So it's true, and we display you can apply, meaning they can apply for a concessionary card. Now from this design, I'm going to produce the program, which you can see is here. And if we have a look at the actual structure of the program, this is the first step here where we can see that we're going to be inputting the user's age. And then we can see we have the selection construct. And within the selection construct, we can see we have the conditional test here, is age greater than or equal to 60. And of course, this will return true or false. Now, if it is true, then we will execute this line of code. And of course, if the conditional test is false, we will execute this particular line of code here. So let's consider the program runtime. We can see that this particular line here has output this string, please enter your age, to this position, and we can see that the user has entered 59. And of course that 59 will be stored in age. So when we come on to do this conditional test here, we're asking is age greater than or equal to 60. We're really asking is 59 greater than or equal to 60. Well, it's not greater than and it's not equal to 60. So this is false, in which case we execute this line here. And we can see that the program runtime actually outputs this string to this position. You are not eligible for a concessionary travel card. So we've seen what the program does when we enter 59. And of course we've got to engage in boundary testing. So we now need to run the program again and test it for 60. And then after that we're going to have to test it for 61. Because we're looking around the boundary of this particular test here. Here we can see another runtime where the user has entered 60. Now consequently, when we come to this particular test here, which is saying is age greater than or equal to 60, we're really asking is 60 greater than or equal to 60? And of course, 60 is not greater than 60, but it is equal to. So this particular test is true. Consequently, this line of code will execute and this line will not execute. So we can now see that the output will put this particular string in this position here. We'll now show the runtime for the program with 61 as entered by the user here. And of course it'll mean that when we do this conditional test, we'll be asking is 61 greater than or equal to 60? And of course it's greater than 60. It isn't equal to 60, but it's sufficient that it's greater than 60 for this to be true. In which case this line here executes and we can see that the output is you are eligible for a concessionary travel card. So we've now seen the program executed with 59, 60 and 61. Let's consider the terminology we use when we deal with relational operators. Here we can see we're relating X, which we call an operand, to Y, which we also call an operand. And we're using this operator. Now this is one of the many operators that are available to us in the Python language. If we look at the other Python relational operators, we can see that they're here. And the column we're interested in is the first column. And it's very important that you actually learn these here. Check out the supporting website for these videos and consider subscribing to the YouTube channel and you'll get an automatic update every time I upload a new video on Python.